In this video, I'll be helping you with the ALEKS problem type called solving a 3x3 system of linear equations, problem type 2. We're given this system of 3 variables and 3 equations to solve. And for problem type 1, we used elimination. For this example, I'll be using substitution, in part because this third equation will be very easy to solve for y, and then substitute back in to those first 2 equations. So working with that third equation to solve for y, I would just subtract the 3x from both sides, canceling the 3x's on the left. I have y equals negative 3x minus 5. This equation we can then substitute into both of the other equations for y, thereby removing all of the y's. So starting with the first equation, we have minus 4x minus 2 times y, but we now know y equals negative 3x minus 5. The rest of the equation has us subtracting z and being equal to 3. From here I can distribute, bringing down the minus 4x, negative 2 times negative 3x, a plus 6x, negative 2 times negative 5, a plus 10, bringing down the rest. We have some like terms, negative 4x plus 6x, a positive 2x, and then this plus 10 can be moved to the other side, leaving a 2x minus z equals negative 7. So with that substitution, I now have eliminated the y from the first equation, and now I need to do the same thing for the second equation to eliminate that y. So here we would have 2x minus 3 times y, which again we now know is minus 3x minus 5. The rest of that second equation is plus 4z equals negative 14. Just as before, we can simplify. First, distributing the minus 3, negative 3 times negative 3x, a plus 9x, negative 3 times negative 5, plus 15. From here, we can combine like terms, so 11x, bringing down the rest of this equation. I could then move this constant plus 15 to the other side by subtracting it, leaving me 11x plus 4z equals negative 29. And with those 2 steps, we've now changed our problem from a system with 3 variables and 3 equations to a system with 2 variables and 2 equations that we can continue to use substitution to solve. Looking at this equation, I can solve for z by first moving the 2x to the other side, leaving me a minus z equals negative 2x minus 7. Of course, we want to know what z is, so multiplying by a negative 1 gives me z equals 2x plus 7. This is now the key to removing z from the other equation, replacing this z with the equation where we've just solved for z gives us an 11x plus 4 times z, which we now know is 2x plus 7 equals negative 29. Solving for x, I would first distribute, so 11x plus 8x, and then 4 times 7 plus 28 equals negative 29. Combining like terms, 19x plus 28 equals negative 29. Continuing to solve for x, I can subtract the 28 to the other side, leaving me 19x equals negative 57. And then for x, we can divide by 19. So x equals negative 3. And while we had to do a lot of algebra to get to this spot, we now know the value of one of the variables, and we can start to use that to find the other variables. So for example, substituting that x in here will give me z. I know that z equals 2 times x, and we now know x is -3 plus 7. So z equals -6 plus 7, or just 1. We have x, we have z. If I look back, I also had this equation that I used earlier where I had solved for y, and we now know what x is. So I can say y equals -3 times x, and we know x is -3. The rest of that equation is -5. So y equals 9 minus 5, or just 4. So we have solved for each of the variables x, y, and z.